Hi, I had another request that somebody wanted me to solve this equation, and again, their problem is assuming a particular solution for the non-homogeneous portion of this equation. And this is a very good example. In fact, by adding this into my collection of videos in this series, I believe if you follow my videos, you will be able to solve any type of equation like this. So let's look. We know that the general solution for equation like this will be y equal to yc plus yp, where yc is the solution to the non-homogeneous portion of that equation, and to find that we can use the auxiliary polynomial and write this portion as m squared minus 2m plus 1 equal to 0. Then we factor this out. We are going to have m minus 1 squared is equal to 0. So our answer will be m equal to 1 twice. So for the repeated root like that, the general answer will be, or yc will be equal to c1 e to power x plus c2 e to power c2x plus c2x e to power x. So this is our yc. And for yp, we need to assume a particular solution for non-homogeneous portion, and this is where a lot of mistakes happen. And as a matter of fact, all the requests on this type of equation have been right here, what to assume as a particular solution for the non-homogeneous portion. Okay, now let's look at the non-homogeneous portion. We are having e to power x, but already we have a repeated solution in our homogeneous portion. We are having e to power x, and we have again a repeated root c2x e to power x. So now we have repeated here again, so our next choice must be a constant. Let's call it a x squared e to power x. And now we have e to power 2x. We have x e to power 2x. So our second part must be a constant multiplied by x e to power 2x. Let's call this constant, let's call this constant b. And I believe whoever asked me to solve this is what he assumed as a particular solution. But there is one thing missing. We got x e to power 2x. So just like a repeated root, we have x e to power x. Now we have x e to power 2x. So definitely we also must have e to power 2x as a solution. So the third part must be c e to power 2x. So this is what we have to assume as a particular solution for that in order for us to solve that. And I believe over 95% of the mistake is students would assume this only and neglecting this part. So the only way to get used to this type of problem, just solve more problems. The more you solve, the better you get. But now, if you look at all the examples that I have posted in my videos, you will definitely find the right answer, the right assumption for your non-homogeneous portion of this type of equation. So this is what we are going to assume. So our general solution y will be yc c1 e to power x plus c2x e to power x plus yp plus a x squared e to power x plus bx e to power 2x plus c e to power 2x. So this will be a general solution for this type of for this differential equation. And if we take the second derivative, the first derivative and second derivative of this assumption and plug it in that equation and compare both sides of the equation, I did that this morning, and I came up for the value for the a to be equal to a will be 3 and b will be 2 and c will be -4. So the general solution for this will be y equal to c1 e to power x plus c2 x e to power x plus 3 x squared e to power x plus 2 bx e to power 2x minus 4 e to power 2x. So again, if you take the first and second derivative of this and plug it in that formula, you will get these answers, and this will be the general solution for that differential equation. So you can go ahead and do that. If you had a problem, let me know. I will come back and solve the whole thing and put the whole thing on a board. The reason I didn't do that is because this is something that I am sure you can do it yourself. But if you have a problem, just let me know.